Hello, geometry students, and welcome back. In this lesson, what we are going to be doing is building on what you've been learning about trigonometry, so sine, cosine, and tangent. Oh boy, right? And knowing that sine, cosine, tangent, and you know the ratios, and hopefully you just keep writing them at the top of your paper every single time. That sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle, oh my gosh, why is this not working? Is opposite over adjacent. Not things you need to memorize. Please just keep writing it, right? It's kind of like your multiplication facts or your addition and your subtraction. You get good at it because you keep doing it. You keep practicing. So given the sides of a right triangle, I will use my knowledge of algebraic equations, right? And solving equations, multi-step equations. And right triangle trigonometry, that's this, to find missing angle measures, right? So we've done a lot of work with finding missing sides and setting up ratios and identifying the sides. You've done work with like finding a side if you have two. You've done work of finding sides and solving the triangle if you have an angle in a side, right? And remember, this is only right triangles. Well, what happens if we've now done the Pythagorean theorem? We now have all three sides, but I don't know the angles, right? I know that those two angles, right? I'll go with the traditional. I want to draw my triangle different this time. 3, 4, 5 right triangle, right? So this is 3, this is 4, this is 5, right? I'll call it triangle FGL. Right, I know that when I take the measure of angle F and I add the measure of angle L to it, I get 90 degrees. I know that they are this word called complementary, but I don't know what they are, right? Like I've got almost the whole triangle solved, but I can't figure out what those angles are. And that's what we're going to be doing in this lesson. So hopefully you've either got this presentation printed or you've got your notebook that you take all of your geometry notes in ready to go. I would also suggest that you have a calculator ready to go, whether it be that you have a graphing calculator, a scientific calculator, or you're using the Desmos scientific calculator that I used in a previous video. That's this one. It's linked on the MyMCPS classroom as well. If you go under geometry resources, it's in there. So, or tech resources, I think. That's in there as well. And so, or just Google scientific calculator, desmos.com/scientific. Great, use it. Some things that you can follow along as well and make sure that you've got this. So let's get started. So we're going to start out by recalling how to use right triangle trig to solve for the length of BC and the length of AC. So I know in this triangle, I've got angle C here, right? I'm going to refer to this as my reference angle. In reference to this angle, opposite is this 12. The hypotenuse is across from the 90-degree angle, right? So don't get fooled by the fact that it's turned. And then adjacent to angle C is this right here. So I'm going to be using 52 as my reference angle. If you choose to use this angle over here, you can, right? I could find that angle. 90 minus 52. Oh, it's a big minus. Is, what is that? That's 838. Right, and I could use that as my reference if I wanted, and just keep in mind opposite and adjacent would switch, and hypotenuse would stay the same. Hey, that's a good challenge. So I'm going to start off by finding BC, and it says to use trig, so I'm going to use trig for both of them. Even though I have my favorite thing called the Pythagorean theorem, I'm still just going to use trig. So BC is this side right here, where I have the A. So I know O, right? Let's write these. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, oh boy, why did I write that so funky? Is opposite over adjacent. I know that I have O, right? I've got O. I don't have A, I don't have H. Well, I'm not going to be using cosine then. If my goal right now is to figure out BC, well, I'm going to be working with O. I know this. I can't not work with it. And I'm going to be working with A and O. Oh, I need tangent. Okay, cool. Tangent of 52 degrees of my reference angle is going to equal to opposite 12 over BC. I'm going to stick it over 1, and I've got BC times the tangent of 52, haven't picked up a calculator yet, equals to 12, and then I need to divide both sides by the tangent of 52, which is just going to be a number. Right, and so BC is going to be whatever this right here is. It's a 2. So I can go into my scientific calculator. I haven't showed you guys a graphing calculator. If you have a graphing calculator, maybe your teacher showed this to you. We want to go ahead and click this button where it says mode, right? It's right next to the second. Click mode. And if you scroll down, it's a little hard to see in here, but there's something called radians and there's something called degrees. Your calculator is going to default to radians, which is something you'll learn second semester, but I'm using degrees, 52 degrees. It's just a unit. It's like measuring something in centimeters versus feet. So I'm going to go over to degrees and click enter, and now I'm good. If I want to quit, I'm going to push second mode because there's a little blue quit for me, and then I'm back here. So I can do 12 divided by the tangent right here of 52, and I get 9.375. I don't know why it doesn't like points, right? I could also do that in my scientific calculator, my Desmos scientific calculator. I forgot what it was. But again, I want to be able to see degrees. I talked about this in my last video. 12 divided by, where's my divided by? Tangent of 52. Oh, look, I got the same thing. I don't even need to worry about it. It's right there. Okay. So I know I got a bit messy, shocking, but now I'm going to go ahead and I've now got A. I now got BC. I'm not going to use the Pythagorean theorem. I'm going to continue to use trig, and I'm going to now be finding AC. I'm going to avoid using a rounded value. So now I'm working with still opposite, but now it's opposite and hypotenuse. So that's sine. So I'm going to say the sine of 52 degrees still, I'm still going to use that as my reference angle, equals to opposite 12 over hypotenuse, which is AC. That's what I'm trying to find. Well, when I go ahead and I cross multiply, AC times the sine of 52 equals 12. Divide both sides by the sine of 52, 12 over the sine of 52. You know what? I can leave it like that if I didn't have a calculator. Or I could go ahead into my calculator and I could do 12 divided by the sine of 52. I'm not going to get the same thing. It's going to be a bigger number. I got 15.228. Right? It makes sense, right? I got a number that's bigger than, it's the biggest side. It's got to be. And you know what? I could like get really crazy here and I could say, well, what happens if I did 12 squared plus 9.375 squared? I get this number. And then what would happen if I did 15.228? I know it's rounded, so it's not going to be perfect, squared. Whoa, I get like almost the same number. Right? That's me checking the Pythagorean theorem. A squared plus B squared, is that equal to C squared? Pretty neat, right? Okay, so we know this. This is what we've worked on the last few periods, right? The last few classes. So I want you to take a step back from this, right? And realistically, we're just solving equations when we're doing this. And I want you to really think about, how do you solve an equation? I'm not concerned if some of these equations you look at and you're like, wow, I didn't know that's exactly how you did that one, right? But I want to show you a variety of different equations. So here I've got just a linear two-step equation. So I'm going to go ahead and, well, I'm going to add 10. And I'm going to add 10. So you've got 2x equals to 31. And then how do I get rid of the 2? That's my goal, right? I'm going to divide it. It was being multiplied, so I'm going to divide it on both sides. I'm going to do the same thing on both sides. So I get the x is 31 halves. Okay, so think about that for a minute. What are you going to do here? I'm going to divide by 2. And I've got x squared equals 16. and then I'm going to take the square root of it. You know, I actually get plus and minus for here. There's two answers. Again, if you're like, what? Why are there two answers? It's okay. But if you do 4 squared, right, 4 times 4 is 16, and negative 4 squared, negative 4 times negative 4 is also 16. So there's two answers. But what I really want you to think about is, okay, so I had to divide by 2, and then I had to take the square root, right? Think about what you're seeing versus what we're doing to isolate it, and like, what's the relationship between those two? And then in this last one, I'm going to add 1. Why am I adding 1? Like, what made me do that? What is a good word for that? And then, well, I can't get inside here yet until I get rid of that square root. Well, I'm going to square it to get rid of it, right? And then I've got 3x equals 25, and then I can go ahead and divide by 3. And I've got x is 25 thirds, because we like fractions more than decimals for this. Right? So think about what you're doing. Like, why were we so seamlessly able to say in number 1 that you add 10? Like, why? Like, I see subtraction, but I'm going to do addition to get rid of it? What's that called? Addition and subtraction are blank. Multiplication and division are blank. Squaring and square rooting are blank. They're what we call inverse operations, which potentially has 2 P's, but I'm not sure. So they're inverse operations, right? Like if you invert something, you're going backwards, you're undoing it, you're getting inside of it. Like I couldn't touch that 3x until I got rid of that square root. Like it was untouchable. I needed to like completely work backwards, right? I had to do divide by 2 before I took the square root, because you're going backwards. It's like I have a list of chores and I'm going to undo it. It's like I packed my suitcase and now I need to take out what's at the top, right? Like you're not going to go right to the bottom. So you have to think about like, how are you peeling those layers away is really what we're doing here. And this is what we're going to be doing with trig as well, right? Like you've just been essentially simplifying. Yes, you've been solving, but you haven't had to like figure out the angle, right? We've only known the angle. So now we're going to really have to use this idea of inverse operations and working backwards. So if I have, let's combine these two skills, what we know about trig and now what we know about what we just briefly chatted about as far as inverse operations. And in example 1 here, my goal is to solve for theta. Theta is my reference angle. Okay, so in reference to this angle, let's label our sides as we do. Nothing's changed. Okay, so theta, you've set up these ratios before. Here's my 90-degree angle, across from is the hypotenuse. Here's theta, here's my reference angle, this is adjacent. Well, I know, right, sine is opposite over hypotenuse, I'm going to abbreviate here. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Adjacent and hypotenuse. I know I'm going to be saying the cosine of theta equals to 12 over 13. And you might be looking at this and you'll be like, that ain't a new skill. We've done that. But how do I get this theta? I have to use the inverse operation. Well, the operation that's occurring is I'm taking the cosine of it. I need to undo that. Well, what's the inverse of cosine? Cosine inverse. That's the name of it. I'm doing the cosine inverse. It's not an operation you've ever done, just like cosine wasn't an operation you've already done, right? It's not that idea. So when we do inverse, it's represented by this little -1. Oh, as like an exponent. So I'm going to do the cosine inverse of both sides. I'm going to back up for a second. So I'm going to do this. I'm going to take the cosine inverse. It won't let me do, it's a -1. And the cosine inverse, there you go. When that happens, if I do the cosine inverse and the cosine, they cancel out and I'm just left with theta. So theta equals to the cosine inverse of 12 over 13. It's how I'm getting inside there. I'm using the inverse operation. Okay, so this is going to be theta. So I'm going to go into my calculator. I'll start with my graphing calculator. And if you see where it says cosine here, and even if you have a scientific calculator, I believe it says this, In blue, it has the cosine with a -1. So I'm going to push the blue button, second cosine, and it'll pop up that way. I'm going to type in 12 over 13, and I get 22.62. 22.62 degrees. Wow, I just found this angle. That then opens this up. I could then find this angle. I could find this missing. This is 5, so Pythagorean triple, right? And then I could do, to find B, I could do 90 minus 22.62 because they're complementary, right? And if I really wanted to like even dive a little bit deeper into what just happened, if I told you to find the cosine of 22.62, 62 parentheses, and enter. Well, we said that was 12 over 13. 12 over 13. Neat. They're basically the same. Pretty cool. If I'm on the Desmos calculator, let's see where it is on this. I can't even see. Function. There it is. If I push function, I could do cosine inverse and then go back to the main page and type in, what was it, 12 over 13? And you'll see it there. If I'm accidentally on the wrong mode, I'm going to get this number that doesn't make sense, right? Like that's a silly angle. Think about it. Okay. Let's do this next one, right? So let's see. I know I'm finding an angle, so I'm going to have to use inverse. So this is my reference angle. This is hypotenuse. I don't need that. So I've got opposite and adjacent. So I'm using tangent. So tangent of theta equals opposite over adjacent. And then just like we did before, let's take the tangent inverse of both sides. I don't know why my -1 won't show up. That's going to cancel, and I'm going to be left with just theta. And I'm going to have theta is the tangent inverse of 4 over 13. So therefore, theta is going to be, let's do it on the Desmos one, tangent inverse of 4 over 13, 17.103. 17.103 degrees. Right? Pretty cool. Pretty cool. So just to kind of extend on this a little bit, so let's say I just straight up had this equation, right? No triangle. I don't need a triangle. I just want to figure out the angle. Well, what am I going to use? Cosine inverse of 9 over 17. Go try it in your calculator. Tangent inverse of 7 over 6. Go try it in your calculator. Whoa. Well, before I can actually do the inverse, just like when we were doing squaring and square rooting, I have to divide by 2. I have to divide by 2. That's the same thing as multiplying by 1/2. Right? If I split something into 2 equal parts, I'm dividing it in half. I'm sorry. If I split something into 2 equal parts, I'm multiplying it by 1/2. That cancels. And then I've got sine of theta equals 8 over 10. So 4/5. And then I would do sine inverse of 4/5. Go try it in your calculator. I'll do it in this calculator. So cosine inverse, second cosine of 9 over 17. If you're not getting this, check the mode. So 58.034 for number 1. Tangent inverse, so second tangent of 7 over 6. 49.399 degrees. And then second sine of 4/5. Sine inverse of 4/5. 53.1301. Okay. What would happen if I accidentally messed this up and here I said cosine inverse? Second cosine, so I'm looking at the second one, of 7/6. Oh my goodness, it gives me an error. The calculator must be broken. No. Cosine is adjacent over hypotenuse. The hypotenuse is always the biggest. So this fraction, adjacent to hypotenuse, is always going to be less than 1. Adjacent to hypotenuse has to be less than 1. That's a 1. So this number is bigger than 1. That's why it gave me an error. Okay, so it was a user error. Okay, so this is the point where I believe I have 8 problems or 6 problems over the next 2 slides. Go ahead and give them a try. So hopefully you've had an opportunity to try these, and I'm going to briefly go over them. Here, let's label our sides. Here's our theta. Make sure you're showing your work. I have adjacent and I have hypotenuse. Therefore, I'm using cosine of theta equals to 6 over 9. I'm going to take the cosine of both sides. The cosine inverse of both sides, which will give me theta equals to the cosine inverse of 6/9. If I didn't have a calculator, I would be good. This would be a wonderful answer. If I do have a calculator, second cosine of 6/9, 48.19. Theta is 48.19 degrees. Okay, let's try number 2. So here I've got opposite and adjacent. That's going to be the tangent of theta is going to be 11.9 over 10. I'm going to take the tangent inverse of both sides. And then I will go into my calculator. Second tangent of 11.9 over 10. 49.958 degrees. 958 degrees is what theta is. Okay, we're plugging along here. What about down here? Well, here I'm finding x. No inverse for 3 and 4, right? You just need to, I don't want you to forget the things that you did learn. Here I've got opposite and adjacent in reference to this angle. So I've got tangent of 50.1 equals to x over 5. So I'm going to get that 5 times the tangent of 50.1 equals x. And I could go into my calculator. Tangent of 50.1 times 5. I did it in the opposite order, but that's okay. 5.998. 5.98. What about this? Do we need inverse? No, I've got the angle. No inverse needed. Adjacent and hypotenuse, pay attention to where your right angle is. So I'm going to have the cosine of 60 is going to be x over 11. When I cross multiply, I'm going to get 11 cosine of 60 equals x. So let's then go into our calculator. 11 cosine, no inverse needed, of 60 is 5.5. 60 is a special angle that we'll learn about. And then go ahead and try these last 3. I believe these are my last 3. Yes, they are. So hopefully you've tried these. These are all coming straight from a calculator. So I'm going to do the sine inverse, right? I would take the sine inverse of both sides. It would cancel out on the right. And then I would go into my calculator and say second sine of 2/3. Oh boy. Second sine of 2/3. If you have a Chromebook, there's actually an extension for a graphing calculator. It's linked on the classroom. If you're not sure where it is, come see your teacher. So theta, I missed it. I wasn't paying attention to my answer. 41.81 degrees. Here, I know that I'm going to have to do the tangent inverse, but let's get rid of that 4 first. So tangent of theta equals 4 times 1/4. Well, that's just 1. So I take the inverse of both sides, the tangent inverse of 1 The answer is going to be 45 degrees. One day you'll know how to do that without a calculator. One day not too far in the future. 45 degrees. Wasn't that pretty neat that I got that? You can hear everybody saying yes. Okay, and then finally, again, I know that I have to do cosine inverse, but I need to isolate that cosine. So I'm going to multiply by 3, and I've got 9 over 5 equals 2 times the cosine of theta. I'm going to divide by 2, which is the same thing as multiplying by a half. So I get 9 over 10 equals cosine of theta. Sorry, my handwriting is like rough. And then I'm going to take the cosine inverse of both sides. So cosine inverse of 9/2 is 9/10 is going to equal to theta. And then I will go into my calculator. Second cosine of 9 over 10, and I get 25.842. 25.842 degrees. Okay. So what we did in this lesson was we did do some review, but we tied in what we know about algebraic equations and solving equations that you guys have really mastered and worked with and like refined over the years in order to determine how to find missing angles, right? And so at this point, we know not only how to solve for missing side, but also for missing angles. So with that being said, make sure that you are working on your homework, the Go formative assignment. Maybe you're even watching this video on that. And that you are coming in and asking questions, and we'll be working with inverse and solving triangles for all missing parts now when we see you next time in class. Thanks everyone for watching, and we will see you all soon.